Welcome to this tutorial about how to create a Python AI service for the IIP-Ecosphere platform. This tutorial has firstly some prerequisites that should be known before watching this video and trying to understand it. And then we will go on with the actual building of an application using a Python AI service. As prerequisites, we should have an installed platform with its dependencies. We should have an IDE we want to work with, preferably the one we provide, as it has some quality of life enhancements. We then need to know how to configure Datatypes, services, applications, as well as how to build an application and how to test an application. You should have seen the videos about these things or have knowledge about how to do these things, as this is a baseline for the contents of this slide set. So how do we actually build an application with a Python AI service? We start firstly with configuring the data types. Like we've already seen, there isn't much new to this. We then define the service. We've seen this once. In this case, we will only highlight the changes, the differences between a Java service. The rest is, like mentioned in the configuring service video. So the service type is a Python service instead of a Java service. The class is left out as it is a Python service. The kind will be a transformation service, and this needs to be a transformation service as other versions do not work. And has dependencies, the Python version it relies on. And it's by default asynchronous, as this is no sync. It will be by default be set to asynchronous if not mentioned. So what do we need these dependencies even for? If we want to auto-generate containers for the Python services, which could be needed in multiple use cases, we would need to know which dependencies the Python service relies on to create them in the container, and thus enabling the automatic generation. But need to import the zip file. About adding resources. If you want to use an AI solution with a pre-trained model, you need to add a model in the same directory as the Python service. An example can be seen on the right side. If you're working with a dev container, you first need to copy the model into the container using Docker CP. More information on this is on the starting the dev container slide set, in which there is some additional information about how to do this with Windows and Windows Subsystem Linux, because this is a bit more complicated. If we're now adding some functionality to this, we have an example in the middle of the screen for this. Here we firstly open the resources trained forest PKL, which is a pickled version of a trained forest model we've copied into our container or just put into our Eclipse project. The method to edit is, as with the Java services, process input data name. And if we want to pass something on, in Python it's just self.ingest, and we input the instance of our new data type. We can see here we load our, so in the code we see here we load our model, set our model as a variable, and then we get our data as a NumPy array, as this is needed to apply our model. If our model exists, to dodge some errors, we predict something, we print the result, and then we create a new output, set the output value, so the value is supposed to be transported to result 0, which is one number of the result, in this case the probability of it being class A, and send it on. After functionality like this is added, you should test everything and finish building the application, like mentioned in how to build an application, and testing is how to test. What we've learned in this tutorial: how to build Python services and how to add resources to the model. This would be all. If you've watched this video and seen every other tutorial video up to this point, you've seen everything that's provided up to this point.